In this video, we will learn how to find the values of the 6 trigonometric functions for an angle theta in standard position if a point with the given coordinates lies on its terminal side. All right, the 6 trigonometric functions, good old sine, cosine, and tangent, and their reciprocals, cosecant, secant, and cotangent. These are the 6 trig functions that we'll be finding. All right, for problem number 1, we have -4, comma, -3. All right. Now, that point is -4 to the left and -3 down. So it's going to be somewhere in this quadrant. All right, 1, 2, 3, this is the third quadrant. So this is my point -4, comma, -3. Okay, let's make a triangle out of it and look at the reference angle. Now, the sine, cosine, and tangent, well, all the 6 trig functions of the reference angle will be the same as the trig functions of the true angle from standard position, give or take a minus sign. So we'll have to be careful about the negative sign. But we can handle that. Because this is the point -4, -3, we know the sides of this triangle. This -4 is the horizontal length right here. So we will call this side of the triangle -4. This -3 is the y value. So it tells us how far down it is. So we will call this -3. We have to include those signs. Now, keeping in mind the definitions of all the trig functions, if I want to do the sine of this angle, we know that the sine is, oh wait, too early. We need to find the radius first. We need all 3 sides before we make the triangle. So clearly the way we will find the radius is by doing the Pythagorean theorem. So we're doing a squared plus b squared equals c squared. So -3 squared plus -4 squared equals r squared. That's 9 plus 16 is equal to r squared. So that's 25 is equal to r squared. Taking the square root, we find that the radius is 5, this hypotenuse. So great, now I know that this is 5. So, as I was saying, the sine is opposite over the hypotenuse. So that'll be -3 over 5. The cosine is adjacent over hypotenuse. So that's -4 over 5. And the tangent is opposite over adjacent. So that is -3 over -4. However, a negative divided by is what did I say? A negative divided by a negative is a positive. So please do not put the negative signs. So these are the original 3 trig functions. Now, we don't even need the picture anymore to write the other the other 3 trig functions, because they are the reciprocals of these. So the reciprocal of the sine function is the cosecant function. So that'll just be 5 over -3. The reciprocal of the cosine is the secant function. So that'll be 5 over -4. And the reciprocal of the tangent function is the cotangent function. So that'll be 4 over 3. I often wonder why these are named this way, because I would have hoped to make it easier to remember that the cosine would be the reciprocal of the cosecant. But that's not the way it is, and I'm sure there's a good mathematical reason for that, but maybe somebody can post it in the comments when you find it out. Anyway, that's it. That's how you find those trig functions for a problem like this. Let's do the same thing for the point -6, 6. All right, the point -6, 6 is going to be to the left 6 and up 6. So it's going to be somewhere here in the second quadrant. So negative 6, comma 6. So let me adjust my triangle. Okay, that's more like it. And once again, here's my reference angle right here. I need all three sides of the triangle so I can do the trig functions. Now, the negative 6 is the x value, so that's going to go on the x-axis. So my negative 6 is going to go here. This positive 6 is a y value. It tells me the height of the point, so it makes sense that this will be 6. Now, I need to find the radius here, the hypotenuse. I could use the Pythagorean theorem, but I can tell that because of these lengths are the same, 6 and 6, that this is a 45-45. This is an isosceles triangle. And I remember the pattern goes leg, 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 radical 2. So I know this is going to turn out to be 6 radical 2 without having to do the Pythagorean theorem. Okay, so if you remember that about your special triangles, great. You know, I'm basically saying I know this is a 45-degree angle. If you didn't notice that, guess what? You just have to do the Pythagorean theorem. So I'll do it real quick. So if I had 6 squared plus negative 6 squared, that's going to give me radius squared. So that would be 36 plus 36 is equal to radius squared. So that's 72 equal to the radius squared. So the radius is equal to the square root of 72. And that turns out to be 6 radical 2. Okay, so we will have the sine is opposite over hypotenuse. So that would be 6 over 6 radical 2. But these 6's are going to cancel out. So that's going to leave 1 over radical 2. Because skirt. All right, we need a 1 up there as a placeholder. All right, similarly, cosine is adjacent over hypotenuse. So that's going to be negative 6 over 6 radical 2. But again, these 6's are going to cancel out. We'll need a 1 up there as a placeholder. So that's going to be negative 1 over radical 2. And finally, the tangent. Tangent is opposite over adjacent. So that would be negative 6, sorry, incorrect. Opposite over adjacent, so 6 over negative 6. So the tangent will be negative 1. All right, once we have these three trig functions, we can just take the reciprocal of them. So the cosecant function, the cosecant is the reciprocal of the sine function. So this will just be radical 2. The secant is the reciprocal of the cosine function. So that'll just be negative radical 2. And the cotangent is the reciprocal of tangent. But that would still be negative 1. So that is it, my friends. All right, I'm going to try to do the same thing for the point 2, 0, but actually this is a special case where we cannot use our normal strategy. We kind of can, but we technically cannot. Okay, we're dealing with the point 2, 0. So you understand that this point is on the x-axis. So we're not going to be able to really make a triangle out of it. You know, you can imagine that that point was right here, okay, 2, 0. All right, it is over 2 units and up nothing. if I tried to make a triangle out of it, so we could do what we normally do, you know, it would just collapse down to a flat line. This program won't even let me shut it down all the way because it's trying to make a triangle. And I'm actually going to go ahead and use that to my advantage. So even though you know that this is not a triangle, this would really flatten out to a perfectly flat line, and there's no triangle here. Let's go ahead and pretend that it is a teeny tiny triangle with the dimensions with an x value of 2 and a y value of 0. So let's see if you can follow me through this strange journey. All right, try to understand that this is like a thought experiment. You cannot really make a triangle out of the point 2 comma 0 because really it's on the x-axis. But if we pretended, now think about it. When this point was really on the x-axis, we know that this was a length of 2, all right? It's just a line. So we know that the radius, if you will, is going to be 2. Okay, so the hypotenuse of our triangle that is so impossibly thin that it's really just a flat line, the hypotenuse would be 2, but guess what? The horizontal length is also 2. Why? Because it's not really a triangle, it's just a straight line. Okay, so obviously the length is 2 and the x value is 2, because in reality it's just a straight line. And the thing is the y value, you know, so I have a radius of 2 and an x value of 2. The y value is 0. So you could think of it as being this little tiny side of the triangle right here, but it's really so tiny that it's 0. So again, would this really make a triangle? Obviously not. There's no such thing as a triangle with a length of 0. But this is a thought experiment that will help you organize in your mind what's about to happen next. All right, so if you think about it this way, you know, this impossible wouldn't really exist in reality way. If you ask yourself, okay, in this strange picture, what would be the sine, cosine, tangent, and so on? Well, the sine of this angle would be opposite over hypotenuse. So that would be 0 over 2. Well, what is 0 over 2? 0 over 2 is just 0. Okay, so the sine of this angle would be 0. Let's keep going. What about the cosine, okay, of this tiny little angle? Well, cosine would be adjacent over hypotenuse, and that would be 2 over 2. But of course, that's just 1, so that would be the cosine. All right, what about the tangent? Tangent is opposite over adjacent, so that would be 0 over 2. But 0 divided by anything is just 0. Okay. All right. Now let's look at the inverse trig functions of all these. Okay, and let's just be very careful about how we do it. So the inverse of the sine function is the cosecant function. Okay, so remember, sine is opposite over hypotenuse. Cosecant is hypotenuse over opposite. So that would be like 2 over 0, hypotenuse over opposite. What's wrong with this picture? Yeah, you can't divide by 0. Okay, so we got this because it was 0 over 2. But 2 over 0 is undefined. So for that reason, the cosecant is undefined. Okay, what about cosine? The reciprocal of that is the secant function. Okay, let's look back at the original triangle. The cosine was adjacent over hypotenuse, all right, 2 over 2. The reciprocal of that is still 2 over 2, so the secant is still going to be 1. All right, now how about the cotangent? All right, remember tangent was opposite over adjacent. So the cotangent is adjacent over opposite. Again, that would be 2 over 0. And again, you cannot divide by 0. So the cotangent is undefined. Okay, so even though this little triangle would not really exist, okay, the point 2 comma 0 in actuality, of course, is not sitting on a tiny triangle. The point 2 comma 0, of course, is actually just on a flat line. But by thinking of this flat line as a really tiny triangle that both has a radius of 2 and an x value of 2, and just with a y value of 0, it does lead you to come up with the correct trig functions. So I think it's a useful thought experiment, even though it's completely invalid in the real world. All right, that's going to be a good place to end this video because the next concept is entirely different. But this is what's going to be on the next video if you're interested. I will meet you over there on the next video.